Okay, so now we're heading up for the last demo of the Show and Tell 2025. So we will have Webstep presenting now, and their contribution to the DISC Show and Tell. They will show us how to digitize today's facility models and make them more valuable and efficient by moving from documents and drawings to structured information models. They have taken today's yellow line process as their starting point and are exploring how they can be renewed and simplified. Webstep uses Huldra as an example, taking this facility from a most outdated to the most modern way of working with a plant. Webstep shows the potential and value of digitizing older facility model. Let's welcome Bård Henning Tvedt and his co-pilot Arne Måge. Welcome.
Thank you. Thank you very much. All right. A lot of cool presentations here today. So thank you for that. It's been very interesting. Are we ready? Good. Right. Please okay, I have the clicker here. No. Virker det ikke? Kan du trykke? Yeah, okay, come on. All right. You work at WebOil, the company that runs Ratatosk, our favorite fictional asset. You stand in the atrium and watch us down on the full-scale model, not full-scale, but the model that's built there. And you kind of think about WebOil and that company. Haven't quite figured it out yet. It's kind of an operator, contractor, and software company all into one. So lately, you have worked as an engineer on the construction part of things, and now you've been pulled into these digitalization projects. Thanks. And yesterday, an incident occurred. A not so cool incident. Have you heard about it? This whale shark ended up in one of the filter packages and reduced the cooling efficiency, nearly leading one of the generators to overheat. So that got you thinking, because you were part of the project that now designed the modification that pulled one of the backup generators out for maintenance. Right? So the situation was even worse because we have the backup generator out for maintenance. So next one, please. As part of that project, you visited the Integrator Operations Center of Ratatosk. And on one of those walls, they've kind of pasted all the legacy PNIDs. They actually had drawn some arrows between them just to show how these PNIDs was connected, the complexity of it. Of course, you were part of a digitalization project, and you're not supposed to work with PNIDs. So what do we do? Well, should we talk about the graph a bit? I said yesterday, not the how, but perhaps we should talk about the graph, because I think we should clean up our data, even though agents kind of emerge. So if you can please click next. This is just a short example of what we get from DXP. We have some nodes, the big circles, and then we have some then we have some DXP nodes, the small green circles, which are connection points. And we have this purple square, which is we have an instrument, or no, sorry, we have an equipment that has a nozzle, and which has a connection point. So this is the structure we get from DXP. It's a really good point of origin. And we have these off and on page connectors as well. The first thing we would like to do is to remove those on and off page connectors. Next, please. Sorry. The first thing we get is, of course, we get some classes from DXP. We get some types. We get to see that things are gate valve, that things are a pump, off-page connector, stuff like that. And then we would like to remove the off-page connectors, right? We don't want the boundary that the PNID gives us. We would like freely floating data. All right, so that was the first thing. And thanks to Semantum, they gave us 4 DXPs. We totally used 7, but yeah, absolutely. It sped up the process greatly. But we would like to extract more information, more of that legacy information. We would like to extract the engineering numbering system. Why? Because it gives us information about what these things are. There's a lot of information locked down into the tag number. And using that ENS, we can extract that information. Next, please. So we get that this PT over to the left is a pressure transmitter, that we have a seawater valve, and that we have a submerged pump, non-submerged motor, actually. Over here is a lift pump. It's a mouthful. So that's the ENS classification. In addition, we get more. Next, please. We get the system, right? All of these things here are part of System 50. What is that? Well, that is low to medium pressure seawater system. What is that? Well, that's a subclass of our utility system. So now we can start to link our systems. Now we can start to link our information. When people refer to semantics, this is often what they refer to, like these taxonomies. All right, but we would like to say something more. We would like to bring in some more, perhaps some standards. Next, please. All right, CFOS. Okay, so we have a seawater valve. We would like to say that that is a subclass of what CFOS calls a manual valve. And that is a valve that is regulated with hand power. We get more information in there. But can we say more? Of course we can. It's a seawater pump, valve, right? Seawater. We would like to say something about the fluid. Okay, so we add more. We add a restriction, saying that we can only have seawater, or it should be seawater that is the fluid in this valve. All right. So we start to see the contours of a graph. Yeah. The next one, please. We go to PostCaesar, and we pick up our engineering symbols. Right? The bottom line there. We have information system symbol, and we have a valve, and we have this submerged pump. Now, next one, please. We would like this to be a distributed graph. We don't want all of this information in every graph we have. We would like kind of to CFOS information. Well, that's in another place, right? All the other things we should include in this graph, like our maintenance information and other information, that should be in different places. It should be a distributed system. We need to connect those systems. And the final one here, please. This is what you see in our graph. When we show you the connected graph that we have, well, this is the part that you actually see of it. You don't see any of the underlying things on the previous slide. You just see these symbols and the arrows. Right, okay, it's time to bring out the big one there. Oops. So now you only see the symbols and the arrow between them, the instruments, the equipment. And what we now have here is that we go back to the what can we do with this? Well, we have marked some of these things without for maintenance, right? We have a modification project, and previously this modification project underwent design, and before it could be built, it went through a yellow line process, a yellow line check. And what is that? Well, it's a consistency check. We would like to make sure that our different data systems have consistent information before we start building. We would like to know that our 2D models and our 3D models are consistent. So basically what it means is that the different engineers come together, compare notes, and start checking. Well, yes, we agree, yes, and we agree for all of these things. Finally, finished. Good. All right, let's go just into our view of things. And let's zoom a bit out. So what we've now done is that we've taken two systems, the seawater system and the power generator system, or the main power system, and said that we would like to do a yellow check simultaneously for both of these systems. It spans multiple P&IDs. It spans multiple pipelines. And to our left here, we have just taken 3 different steps in the yellow line process. It is more, it's quite a long checklist, but that was what we had time for. So if we now start with tag synchronization. This is just, yeah, please. Now we've taken the 2D model as origin, and then we would like to fetch data from our 3D model. And this is something that now should just work, because there's a synchronization that is in place between the different systems, so that when you generate a tag in one system, well, then it should be automatically generated in the other system. But still, a verification, just to have a verification in place, might be a good thing. So here we see that, okay, well, we just missed some information in the 3D model. We checked, like, we could do a kinematics tool, all right? Go straight into the 3D model, see, well, that is there. We just have named it something different. Fix that here or in the 3D model. Just to say, we do not, like Webstep, do not have a product. We just create these things to demo what's possible. And that means that proper tools, like Cadmatic or Draga and stuff like that, that's what could be used to solve these work processes in the future. AD750, for instance. Something like that. Okay, so now if you zoom in on the graph itself, we've basically taken that big graph, and then we said we will just look at this subset. We don't want all the information that's in the P&ID. We would just like to see a small subset. Let us ask this question. If we have proper structured data, do we need the P&ID? Yes, ooh. Well, I joked about Viking yesterday, and now this, huh? It's like swearing in church. All right, let's step next. Now we're into property verification. We would like to ensure that the properties of the different, yeah, that should have been a seawater valve. But we would like to see that the properties are the same in both places, right? So if not, yeah, okay, you can fix that if you like. But if we go to the other one, if you scroll to the right there, we have a valve, right? In one system, it is a control valve, and in the other, it's a pressure safety valve. Yes, okay. So we would like that to be the same. And we also see that this symbol, that's open. That might be how they drew it back then, but I don't think a safety valve should be normally open, so we would like to fix that. We go in, edit the type, we get from the 3D model that this should be a pressure safety valve, that close, yes, and we try again, and now let's see, we also get a new symbol from the PCA library, right? Based on the type, we could state what kind of symbol should you use for this. All right. Yeah, just I think we can go to the property breaks part of things. Yeah, property breaks, right? That the specifications of your pipeline somehow changes somewhere. That's what the property breaks are for. And in this case, hope you guys down there can see, we have a 3-inch valve with a 3-inch pipe that goes into an expander, so it becomes 4 inches. Down here we have a pipe, 3-inch, connects directly to the 4-inch pipe. I assume, again, this is how it's drawn, right? We have this 3-inch valve connected to the 4-inch, we have these two pipelines, 3-inch, 4-inch, connected to each other. That's fine because it's two different pipes, right? But we don't express this in the data. It's the drawing talking, right? We need to get this into data. So that's what we think we should do. Well, at least when we check these things, we get errors, and we need to add reducer and expander. Can you, if you scroll, yeah. If you zoom a bit out. Ooh, there we have it. So that's the mark where we have a valve that is 3-inch and it goes into a 4-inch pipe without anything in between. I think we should express that thoroughly in the drawing and not the least in the data. So just please add the expander. All right. Yeah. Well, we had planned a couple of more steps. We wanted to look at fluid flow, for instance, that they were in the correct direction and that all the instruments were correctly oriented. So we asked the engineers, and they say, yeah, well, we look at the general assembly or the general arrangement. This is a general arrangement. Well, okay, it's not for one of the valves, it's for the heat exchanger that we talked about yesterday. I don't have the skill to kind of read this thing. But we somehow need to get that information into the data. If we would like to check what arrangement, what orientation your equipment have, well, that's a data requirement. It's what we talked about yesterday. We need to find the use cases that specifies the data requirements. And I've talked to Jonathan. He told me about these that you needed, well, 5 meters of straight pipeline to get your instruments working. Aslan, you mentioned that yesterday as well, right? Where's the data for it? Right? We need to get that into the model. We don't have that kind of information in the graph yet. This is a new data requirement. We have to create those data. Right. Okay, let's move on. Finalize. Yes. Okay, we have an issue remaining. That was, I guess that was a seawater valve that became something else. Yeah. Well, that's good. We have issues remaining. We shouldn't be able to complete it. We aren't able to complete it, are we? No? Good. Okay. Of course, there's walking the line. For a brownfield, we not only need to make sure that our models are consistent, we need to take actual data of how the physical asset looks. We need to do the scans, we need to do the inspections, and we need to combine that with the data we have in our models. So lots of things that need to be in place. And I was so fortunate to be able to start the conference with this, right? That DISC needs to write their book, Color of Data, that describes the use cases, the business use cases. What do we actually need? I think yellow lining should be among them. And I think we have here data requirements when it comes to flow, orientation of equipment, like the length of free pipe. A good example of what we are looking for when we try to make data models for this, when we try to turn that unstructured information into structured information. So complete the color of data so that we can unleash the magic of data. Yeah. Oh, yes, important. Thanks to Semontum for the DEXP. Excellent. Yes. Thanks to Equinor for allowing us to use STID for Hullra. That was excellent. PCA for the symbol library. And of course, Aker Solutions and Equinor, we've been able to talk to some of your engineers. Thank you very much for that. That's extremely helpful. The end. Thank you.
Thank you so much, Webstep, and thank you for being the only consultancy company joining in the DISC collaboration. Been a part of it for many years now, always showing exceptional stuff and being real role models within the DISC collaboration. Thank you so much. Comments from the technical committee?
Once again, thank you very much for your presentation, your demonstration. A couple of things I'd like to comment on, and I think you're just about the only people that have actually posed that question: why do we need P&IDs? Why is this industry constrained by a piece of A1 piece of paper that used to fit on a drawing board? And why do we need all those off-page connectors? I like the idea of having a plant model, a true 2D plant model that can be navigated, can be used for verification. And actually, to your question, do we need the P&IDs? In my view, the answer is no. We need some technology that allows that representation to be in the control room on the offshore assets, that allows them to use and get that increase in efficiency, but it reliably, so that should they have any systems failures out there, they can still perform black starts and all those other things that they need to perform. But I wasn't going, I was going no. Again, thank you very much. Thank you.
Thank you.